I'm using my moment of inertia device in order to measure the moment of inertia of a flywheel that I've designed and built to go on my ball machine. I have an 8mm shaft that's going to be going through this PETG hub, and then the external material is this flexible TPU type of material. And then in order to mount it on my device, I use these mounts that go into the 12mm openings in my torque wheel on my flywheel, and then those look like this. They hold on to the to the side of the wheel, and then they go into the 12mm openings that are in the flywheel itself. Here's my launch wheel system set up to measure the moment of inertia of the launch wheel that I'm going to be using on a ball machine. So we have the Arduino here and the SD card that's saving all the data. And then back in here we have the IR sensor. Here's the encoder wheel that has all of the gaps in it that'll be recognized by the sensor. Here's the flywheel that is being used to mount my launch wheel. And then this launch wheel is printed out of flexible material as well as PETG for the hub. All right, and I'm ready to set and release the device. So I go to my Arduino sketch, and I'm going to give the sketch a name, and it's going to be a CSV file. And now it's ready to get going, so I'll tell it to start. And it's ready, so now I'm going to release the brake. And now it's ready to drop. Okay, so try and get it steady. And check to see that we've reached our 100 times of spin. And everything is saved, so now I'll check the file with my Python program. Now I'm ready to run my regression Python code. And so I'm going to run it, and the results that I've been getting show that my travel is about a little less than 0.9 meters. My rotational acceleration is on average somewhere around 15 meters per second. And my equivalent RPMs is somewhere around 3250, and that's the value of the slots, if you consider them as RPMs. And here's my rotational rate, omega, radians per second. And down below here, I'm getting a value for my moment of inertia that's pretty consistent over multiple drops using my moment of inertia measuring system. And it's giving me 0.003, and that's kilograms meters squared.